6.2 released. We are excited to announce Swift 6.2, a release aimed at making every Swift developer more productive, regardless of where or how you write code. From improved tooling and libraries to enhancements in concurrency and performance, Swift 6.2 delivers a broad set of features designed for real-world development at every layer of the software stack. Read on for deep dive into changes to the language, libraries, workflows, platform support, and next steps for getting started with Swift 6.2. Approachable concurrency. Swift 6.2 lowers the barrier to concurrent programming with a set of changes designed to reduce boilerplate and let you write safe concurrent code more naturally. Single threaded by default. Run your code on main thread without explicit @main actor annotation. Using the new options to isolate code to the main actor by default. This option is ideal for scripts, UI code, and other executable targets. Intuitive async functions. Write async code without concurrent access to mutable state. Previously, non-isolated async methods always switch to the global executor that manages the concurrent thread pool, which made it difficult to write async method for class types without data race safety errors. In Swift 6.2, you can migrate to an upcoming feature where async function runs in the caller's execution context even when called on the main actor. Opting into concurrency with @concurrent. Introduced code that runs concurrently using the new @concurrent attribute. This makes it clear when you want to remain serialized on actor and when code may run in parallel. Together, these improvements let you write data race free code with less annotations overhead, providing more predictable behavior for async code while still allowing you to introduce concurrency when you need it. Safe systems programming. Swift 6.2 includes features designed to maximize performance without compromising safety. These features help you write safe low-level code with predictable performance and minimal overhead. Inline array is a new fixed-size array with inline storage for elements which can be stored on the stack or directly within other types without additional heap allocation. You can introduce an inline array by writing the size in angle brackets before the element or by using the off shorthand syntax. The new span type offers safe direct access to contiguous memory. Span maintains memory safety by ensuring the memory remains valid while you are using it. These guarantees are checked at compile time with no runtime overhead and define away the memory safety problems inherent to pointers such as use after free bugs. Swift 6.2 enhances its capabilities for low-level and security-critical projects beyond new APIs. Embedded Swift. Embedded Swift now includes Swift full-string APIs, any types for class constraint protocols, and the new inline array and span types. Safe C++ interoperability. Projects that mix Swift and C++ can take advantage of Swift's safe abstractions like span for C++ APIs through header annotations. Opt-in strict memory safety. Swift has provided memory safety since its inception while allowing use of unsafe constructs like unsafe pointers when needed, such as using C API that accepts pointers. Swift 6.2 introduces opt-in strict memory safety which flags uses of unsafe constructs so you can replace them with safe alternatives or explicitly acknowledge them in source code. It's opt-in because the majority of projects don't need this level of enforcement. Strict memory safety is best left for projects with the strongest security requirements. Streamlined workflows. Beyond language improvements, Swift 6.2 smooths the day-to-day iteration cycle of editing, building, and debugging code. VS Code Swift extension. The Swift extension for VS Code is now officially verified and distributed by Swift.org. The latest version of the extension includes background indexing by default, write code with fast, always up-to-date editor, features like jump to definition and code completion, built-in LLDB debugging, step through Swift code, set breakpoints and inspect state using LLDB right inside VS Code. Swift project panel. Navigate your Swift project's target dependency and task in the Explorer view. Live docsy preview. Preview your render documentation side by side with your code. Updated live as you type. This workflow improvements makes it easier to work on Swift projects in your environment of choice with first-class tooling. Swift 6.2 enhances how you manage compiler warnings by allowing control at the diagnostic group level. A diagnostic group is a category of warnings identified by name. You can specify the desired behavior of warnings in a diagnostic group in a Swift package manifest using the treat warning method on Swift settings or promote all warnings to errors using the treat all warnings method. For example, you can promote all warnings to error except for warnings about uses of deprecated APIs. Macro build performance. Swift 6.2 significantly improves clean build times for projects that use macro based APIs. Previously, the build system had to first fetch and build the Swift syntax package from source before building the macro project, which noticeably lengthened compile times, especially in CI environments. Swift Package Manager now supports pre-built Swift syntax dependencies, completely eliminating an expensive build steps. Swift 6.2 makes it much easier to follow what's happening in concurrent code when debugging with LLDB. Robust async stepping. Reliably step into asynchronous functions in LLDB even when the async call requires switching threads. Surfacing task context. See which piece of code is running on when stopped at a breakpoint and when viewing the backtrace for the current thread. Name task. Assign human readable names when creating tasks which are surfaced in the task context in debugging and profiling tools. Migrations to upcoming features. Swift 6.2 introduces migration tooling to help you adopt upcoming language features, identify source incompatibility, identify code patterns that will no longer compile or change behavior when the upcoming feature is enabled through warnings from migration tooling. Automate code changes. Apply fix its to update your code to preserve its existing behavior. This streamlines the process of enabling upcoming features by eliminating the tedious task of manual code changes. You can learn more about migration tooling in the Swift Migration Guide. Core library updates. Whether you are managing external process, reacting to state changes, or writing test suites, the Swift 6.2 libraries are evolving to help you write cleaner and safer code. Swift 6.2 introduces a new sub-process package that offers a streamlined, concurrently friendly API for launching and managing external process. This includes API build with async await, fine-grained control over process execution, platform-specific configuration, and more ideal for scripting, automation, and server-side tasks. Explore the full API surface for version 0.1 in the Swift sub-process repository, and feedback from your adoption will inform the API that is released in version 1.0. In Swift 6.2, the foundation library includes a modern notification center API that uses concrete notification type instead of relying on strings and untyped dictionaries for notification names and payload. This means you can define a notification struct with stored properties, and observers can use the type without error-prone indexing and dynamic casting. Notification types also specify whether they are posted synchronously on the main actor or asynchronously through a conformance to main actor message or async message, which eliminates concurrency errors when working with main actor notification. Observation. Swift 6.2 enables streaming transactional state changes of observable types using the new observation async sequence type. Updates include all synchronous changes to the observable properties in the transaction ends at the next await that suspends. This avoids redundant UI updates, improves performance, and ensure that your code reacts to a consistent snapshot of the value. Swift testing. In Swift 6.2 adds new API for enhanced expressivity in your test and test results. Exit testing lets you verify that code terminates under specific condition such as failed precondition. Your exit test run in a new process and validate that exit behavior is what you expect, making it possible to exercise critical failure paths like you would in any other test. Attachments let you include additional context in test results, including strings, images, logs, and other artifacts surfaced in test reports or returned to disk. This makes it easier to diagnose failures with concrete evidence, whether that's a screenshot of a UI state, a JSON payload, or trace of steps leading up to the issue. Raw identifier display name lets you customize the name of text functions and suit types with less code. WebAssembly support. Swift 6.2 gains support for WebAssembly, also known as WASM. WebAssembly is a virtual machine platform focused on portability, security, and high performance. You can build both client and server application for WASM and deploy to the browser or other runtimes. Learn more about WASM in the vision for WebAssembly support in Swift. Thank you to everyone who shared their experiences, frustrations, and insights that guided the design of Swift 6.2. especially the approachable concurrency model. Your feedback made it clear where the language could be friendlier, where safety needed to be more natural, and where the tools could make you more productive. The improvements in Swift 6.2 are only possible because of your voices. If you are excited about where Swift is headed, there is no better time to get involved in the Swift community. From participating in Swift evolution to contributing code on GitHub or sharing feedback on how the language feels in real world projects, every voice helps shapes Swift's future. Whether you are a seasoned programmer or just starting out, our community thrives on collaboration and welcomes new perspective. Join in, learn from others, and helps make Swift a better language.